Good morning, students. Our subject is Design of Concrete Structure 1. Our today's topic is Limit State of Collapse Shear, Part 2. In a Part 1, we studied introductory part about shear. What is shear? Reinforcement of shear. What is minimum shear, maximum shear, with shear reinforcement, without shear reinforcement bars. In today's lecture, we are going to solve some numerical example of shear reinforcement. So, example number 1. Design a shear reinforcement for the beam of size 250 mm into 440 mm. So B is 250 mm and D, here a cover is given, so this D consider is capital D. Capital D is 440 mm. How to calculate effective depth? Effective depth is equals to capital D minus C. C is 440 and cover is 40. So 440 minus 40, that is 400 mm is effective depth. Okay. Of span 4.25 meters. So L is given 4.25. UDL is given 17.5 kilonewton meter including self weight, means here W is given. If we have to calculate factored UDL, then multiplied by 1 into 1.5, so 17.5 into 1.5, that then the beam is reinforced with. To calculate AST, here bar is given 3 number of bars of diameter 16 mm. So 3 number of bars diameter is 16 mm. So 3 into pi by 4 into d square, we got AST. Then use the grade of concrete is M20 and the grade of steel is Fe415. So given data is here. Width is 250 mm. Capital D is 440. So cap 440 minus 40, here we got effective depth. Okay, for what is 40? 40 is a cover. Okay, so W is given here 17.5 kilonewton meter. So W into, if we have to calculate WU, then WU is W into gamma F. So 17.5 into 1.5, that is 26.25 kilonewton meter. And L effective is given 4.25 meter. AST 3 bar of 16 mm diameter. So 3 number of bar is 3 into pi by 4 into diameter is 16 square. So AST is 603.19 mm square. Now we have to calculate here factored shear force VU. How to calculate VU? VU is WU into LE divided by 2. So what is WU? 26.25. Here we already calculated 26.25. So 26.25 LE is 4.25 divided by 2, that is VU is 55.78 kilonewton. Okay, after VU we have to find first step here is calculation of nominal shear. How to calculate nominal shear? Formula is VU divided by BD. What is VU? 55.78 into 10 to the power 3 Newton divided by B is 250 mm and D is 400 mm. So nominal shear is 0.56 Newton per mm square. So nominal shear tau C is 0.56 Newton per mm square. If we have to find maximum, check for maximum shear. So nominal shear is equals to maximum shear reinforcement. Nominal shear is 0.56 and maximum shear, here is one table is given, maximum shear tau UC. So tau UC is for our the grade of concrete is M20. So for M20 tau C maximum is 2.8. In IS code this table is already given. So from M20 here tau C maximum is 2.8. So maximum is 2.8. 0.56 is less than 2.8. So safe. Okay. Now second step, calculation of design shear strength of concrete PT limited, means percentage limited we have to calculate here. How to calculate percentage limited? So AST divided by BD into 100. AST we already find 3 bars of 16 diameter is given, so 3 bar of pi by 4 into d square, so 16 square. So here we got 603.19. B is 250 mm and D is 400 mm, into multiply by 100. Why we multiplied 100? Because in percentage we have to calculate PT limited. So PT limited is 0.6 percentage. If 0.6 percentage is given, so here for 0.6 in table our grade of concrete is M20 and our percentage is 0.6. In this table where is value 0.6, but 0.5 is value for M20 is 0.48 and 0.75 value is 0.56. Between these two we got 0.6. So this value write in one table. 0.5 is 0.48 and 0.75 value is 0.456. So in this table we we only write PT percentage is for 0.5. Tau C, here the grade of concrete is M20, so tau C value is for 0.5 value is 0.48. For 0.6 we don't know value, so we have to find here. 0.75 value is 0.56. So how to calculate PT tau C for 0.6 percentage? So first 0. In this 0.48, take here 0.48. How to calculate this? Simply from in this value add plus 0.56 minus 0.48 divided by 0.75 minus 0.5 and multiplied this 0.6 minus 0.5. So we got PT percentage for 0.6 tau C value. So interpolation, that is 0.48 plus 0.56 minus 0.48 divided by 0.75 minus 0.5 into 0.6 minus 0.5. The value is 0.51 Newton per mm square. How we calculate? By interpolation. How to understand it? First this value add this 0.56 0.48 plus in bracket 0.56 minus 0.48 divided by 0.75 minus 0.5 into multiplied this 0.6 into 0.5. So we got this value. This value is 0.51. This value is in between these two. Upper value is 0.48 and lower value is 0.56. Our value is 0.5. So it is correct. Okay. What is in third step we have to compare nominal shear and design shear. Nominal shear is 0.56 and how we get nominal shear? In first step we already find here nominal shear value. Here calculation of nominal shear, in first step we already calculated nominal shear is 0.56. so our nominal shear is 0.56 and design shear is 0.51. so here nominal shear is greater, so shear reinforcement is required. If design shear is greater, then no required to design shear reinforcement. So here shear reinforcement is required because nominal shear value is greater than 0 design shear. Nominal shear is 0.56 and design shear is 0.51. So because of that we have to shear reinforcement is required. Now due to this third step shear reinforcement is required, So after that we have to design this step number 4. If shear reinforcement is not required, then no need to use this step number 4. Okay, so shear force resist by shear reinforcement VUS. So VUS equal to VU minus VUC. In first step we already find VU is 5.78. What is VUC? VUC is design shear into B into D. Design shear is 0.51 into 250 into 400 into 10 to the power minus 3. So VUS is 55.78 minus this answer is 51. So value is 4.78 kilonewton. VUS shear force resisted by shear reinforcement is 4.78. Assume the diameter 8 mm because it's required a stirrup. So stirrup doesn't require a large diameter, so use 8 mm and two-legged vertical stirrup as a shear reinforcement. You know what is a two-legged shear? It is called as a two-legged shear. We design like this, so it is called as a uh, two-legged shear. In first introductory part we already studied about two-legged, four-legged and six-legged shear. So in this example we assume 8 mm diameter and two-legged vertical stirrup as a shear reinforcement. In next step, spacing of shear reinforcement, we have to calculate here spacing between these two reinforcement. So SV here third step we have to find to calculate shear reinforcement. First is 0.87 Fy into ASV into D divided by VUS. So 0.87 Fy is 415. What is ASV? ASV is mm, area of vertical legged bar. So two our leg is two legs, so consider here two legged. Pi by 4 into diameter we assume here 8, so 8 square. So 2 into pi by 4 into d square, diameter is 8, so d is 400 divided by VUS. We already find here VUS is 4.78, so 4.78 into 10 to the power 3 Newton. So answer of SU is 3037.38 mm. Second, we have to find here minimum reinforcement. So minimum reinforcement is 0.87 Fy into ASV divided by 0.4 B. 0.87 Fy is 415 ASV. ASV means 2 legged into pi by 4 into d square divided by 0.4, and d is 2. Our value of d is already given here 250. So take B is 250. So answer of SB is 362.97. Third, to calculate SB is 0.75 into D. 0.75. D is 400. So take answer is 300 mm. From these three, first is 3037.38. Second is 362.97, and third is 300. So from these three, which value is less? 300 is less, so use whichever is less. We use here 300 mm. So width is beam width is 250 mm, overall depth is 440 mm, effective depth is 400 mm, cover is given 40 mm, 8 mm in here diagram of longitudinal section of beam. So here required shear, here we used 8 mm diameter two-legged vertical stirrups. Okay, the spacing between these two is 300. Okay, after solution we have to draw longitudinal section of beam and cross section of beam. Okay, so by using this step we design shear reinforcement. In first step we find VU. After that we calculated VUS required, and compare nominal shear, design shear, maximum shear, and after that we design here SV, spacing between two bars. Okay, and then draw cross section and longitudinal section of beam. Second step is second numerical we have to solve here. Example number 2, that is a beam 230 mm by 450 mm effective subjected to a factored shear force of 30 kilonewton. Means a beam is 230 mm, means B is given 230 mm. 450 mm means effective is given, so effective is 450 mm. uh, 30 kilonewton factored shear force means VU is already given 30 kilonewton. Design shear reinforcement, we have to design here shear reinforcement. So the beam is reinforced with, so AST 2 bar of 20 mm diameter, so 2 bar pi by 4 into d square. So AST is 628.32 mm square. Use M15. The grade of concrete is M15 and the grade of steel is Fe415. So given data, B is 230 mm, FCK is 15 mm, D effective depth is 450 mm, Fy is 415 MPa, VU is 30 kilonewton, AST is 2 bar of 20 mm diameter. So AST is 628.32 mm square. So in first step, we have to find nominal shear reinforcement. So how to calculate nominal shear reinforcement? Nominal shear reinforcement formula is VU divided by BD into B divided by B into D. So VU is given 30 into 10 to the power 3 Newton divided by B is 230 and into D is effective depth is 450. So our nominal shear is 0.29 Newton per mm square. Check maximum shear. So nominal shear is 0.29 and maximum shear is 2.5. From we take here table maximum shear M15 grade, our the grade of concrete is given M15. So for M15 value is 2.5. So safe because maximum shear is greater uh, as compared to nominal shear, so it is safe. Now calculation of design shear strength PT limited, we have to calculate here PT limited percentage. Formula is AST divided by B into D into 100. AST is already given 628.32 divided by B is 230 and D is 450 into 100. So PT percentage is 0.6%. So in this table our the grade of concrete is M15. So for M15 our value is different, our percentage is 0.6. So between these two here our percentage, so for 0.5 value is 0.46 and 0.75 value is 0.54. So we write in this table percentage is 0.5. So for tau C is 0.46, our percentage is 0.6 but we don't know value. 0.75 value is 0.56. How to calculate value for 0.6? So by interpolation method. How to interpolation? 0.46 plus bracket, in bracket 0.54 minus 0.46 divided by 0.75 minus 0.5 into multiplied this 0.6 minus 0.5. So we got the answer of tau C for 0.6. So here interpolation, first value is 0.46 plus 0.54 minus 0.46 divided by 0.75 minus 0.5 into 0.6 minus 0.5. So interpolation value is 0.50. So this value is 0.50. This value between these two, so it is correct. Compare nominal shear and design shear. Our nominal shear we already calculated here. our nominal shear is 0.29. In first step, nominal shear is 0.29. So our nominal shear is 0.29 and our design shear is 0.50. So shear reinforcement is not required because design shear is more. So here shear reinforcement is not required. So not necessary to calculate VUS. Here no necessary to calculate VUS. So find SV, spacing between stirrup. So spacing between stirrup is 0.87 into Fy into ASV divided by 0.4b. So 0.87 Fy is given 415. ASV we assume here two-legged. uh, Two-legged means 2 into pi by 4. We assume diameter is 8 square divided by 0.4 and B is 230. So SV is 394.53 mm and second SV is 0.75 d. Our effective depth is 450. So 0.75 into 450, that is 337.5 mm. But these two values is more than 30. Our formula is use whichever is less, but these two values are more than 300, so we use 300 mm. So use provide 8 mm diameter two-legged vertical stirrup at about 300 mm center to center, because we do not having a permission to use spacing more than 300. These two values is more than 300, so we consider spacing is 300 mm and we use here two-legged stirrup. Okay, so this is a cross section of beam and this is a longitudinal section of beam. Our spacing is 300 mm and we use 8 mm diameter of two-legged vertical stirrup at 300 mm center to center. Okay, so in today's lecture we solved two numerical example to design a shear reinforcement. So anyone having doubt in today's lecture, you can put your question in chat box. Okay, thank you.